Hello, my scholars. Miss Ramey here to do a video on one-step equations. I will start with one-step equations and then I will pause and we will come back with how to do two-step equations. Now, a couple of weeks ago, I did a video introducing the concepts. I talked about understanding what it is that we are looking for and understanding the opposite when we are solving equations, because that's ultimately what it's about. You have to know the four basic operations of mathematics. You also have to know their opposites, and that is what's going to help us when we are solving our equations, whether it's one step, two step, whatever the case may be. Understanding those operations and their opposites is a good bit of the battle when it comes to solving equations. So with that being said, let's talk about it a little bit, just to do a little bit of a review. We know that the four basic operations of mathematics are addition, subtraction, multiplication, and division. And then we also know that their opposites are, so the opposite of addition is subtraction, the opposite of subtraction is addition, the opposite of multiplication is division, the opposite of division is multiplication. Um, like such, right? And vice versa. So subtraction's opposite is addition, addition, subtraction, yeah, like what we said. So some things that I added here is how they are displayed. We know when we're looking at addition, you're going to see a plus sign. When you're looking at subtraction, you're going to see a minus sign. And same thing, subtraction, plus sign, subtraction sign, plus sign. When we're talking about multiplication, many times we are going to see parentheses. I explained to you all that we get away from using the actual multiplication sign because when we are solving equations, x is often one of our variables and we don't want you to be confused. So instead of using the multiplication sign, we may use parentheses. We may use a dot as well, to signify, or we may or you may see a number and a variable next to each other. So something like 4m, and that simply means 4 times m. So if you see a number and a variable next to each other, that signifies multiplication. For division, division is we use a fraction because fractions in mathematics is division. So when you see division or when you see a fraction, that means your operation is division. So one of the things we talked about in the last video was understanding the original operation of your problem. And when you understand the original operation of your problem, it allows you to know what is your next step because you're going to use the opposite of that to solve. So if the original operation of your problem is addition, we are going to use subtraction to solve. If the original operation is subtraction, we are going to use addition to solve. If the original operation is multiplication, we use division to solve. And if the original operation is division, then we use multiplication to solve. I hope that's making sense thus far. So let's get into it. Let's try some practice problems. So in class, I gave you all some questions to ask. So the first question that you should ask yourself is, what is the original operation of this problem? So when we look at s plus 19 equals 2, the original operation is what? The original operation is addition. So we understand that because the original operation is addition, we are going to use the opposite operation to solve. The opposite operation of addition is subtraction. So what you can note to yourself is that if I know that the original operation is addition, to solve the problem, I'm going to use the opposite of that, which is subtraction. Now, the next thing I want you to ask yourself is, hey, when this problem is all said and done, what should I see at the end? And what you should see at the end is S equals something. Because when we are solving equations, we are trying to figure out the value of the variable. The variable signifies that there is a number, but we don't know at this particular moment what the number is. The unknown, in other words. And so we want to figure out what is the unknown. That's our goal. And so at the end, we're going to say the unknown, or S, equals what we didn't know, a number. Okay? That means if we're going to figure out what S is, we have to get S by itself. So there's two sides of the equal sign. You have the left side of the equal sign, you have the right side of the equal sign. The left side and the right side. On the left side of the equal sign in this particular problem, we have S plus 19. On the right side, we simply have the number 2. What we are trying to do is get S on this left side of the equal sign by itself. In order for us to do that, we have to get rid of what it is that is on the side, what is on the same side of S, that is keeping S from being by itself. So when we look at this problem and we see, hey, on the left side of the equal sign, we have two terms. We have an S and we have a 19. But I don't want to have two terms. I only want to have one, and that is S. So that means I have to get rid of something. Well, if I want to have S by itself, that means I have to get rid of what is next to S, or what is with S, and that is 19. As you see, there is a positive 19 or plus 19. Remember I told you add plus positive, they're all the same thing, okay? So we have plus 19 or positive 19. In order to get rid of positive 19 or plus 19, we have to do the opposite. And the opposite of plus 19 is minus 19. The opposite of positive 19 is negative 19. So here, I'm going to use another color so we can signify that we're doing something. We are going to get rid of 19 by simply subtracting or taking the opposite. So the opposite of positive 19 is negative 19, or the opposite of plus 19 is minus 19. See, it's the same thing. All right. What we do on the left side of the equal sign, we have to do the same exact thing on the right side of the equal sign. So since we subtracted 19 here, we have to subtract 19 on this side of the equal sign. Okay? Got it? I got that? Yeah? All right. So what then happens, remember we talked about that thing called an additive inverse? And when we have an additive inverse, that is simply when we take a number and add its opposite. When we do that, it becomes 0. Or as we say in class, we cancel culture. So this becomes no more. There it is. So these no longer exist. So the only thing that is left on this side of the equal sign is what? S. We have accomplished our goal of getting S by itself. And then we simply keep our equal sign. And then we do the math. 2 plus negative 19. 2 plus negative 19. So if you need me to put it in context, that looks like such. 2 plus negative 19. We have two different signs, thus we are going to subtract. So 19 minus 2 is 17. And then we keep the sign of the larger number. The larger number in this case is 19. So the answer is negative 17. So S equals negative 17. Okay? What we're saying is, if I was to go back, instead of putting the letter S now, I know it's no longer unknown. I now know that S is negative 17. So I can say negative 17 plus 19 equals 2. And that is a true statement. So that is when we are adding. So this was The original operation was addition. We used the opposite, which was subtraction, to solve it. Let's move to this one. The first question, the original operation. The original operation is subtraction. Thus, we are going to use addition to solve it. At the end of this, we want to know the value of t. So we should get an answer that says t equals something. Okay? So, we want to get t on this side of the equal sign by itself. The way to do that is to get rid of what is causing t to not be alone. In this case, it is negative 12. So we're going to get rid of negative 12 or minus 12. The way to do that is the opposite. So t minus 12 equals 6. The opposite would be plus 12. So we're going to add 12. And remember what we do on this side of the equal sign, we also do it on the other side of the equal sign. Here's our additive inverse. We cancel culture right there. So those go away. And t equals 6 plus 12 is 18. So what we're saying is, if I had to remove the letter t and place a value there, I would place 18 there. And what I would find is 18 minus 12 equals 6. Okay? All right, let's move on. This is where it gets a little bit tricky and confusing for some of you when you start seeing the different operations that are not addition and subtraction, which is why I wanted to point out ways that they are displayed. So whenever you see a number and a letter next to each other, that signifies multiplication, or a number and a variable. That is multiplication. Okay? The original operation in this problem is multiplication, because you have a number and a variable. What we are saying is 8 times y. This is the same as saying 8 times y equals 48. And so what we are asking ourselves is, hey, what number times 8 is going to give us 48? So the way to solve this is, again, we ask ourselves, what's the original operation? Just figured out it is multiplication. If the original operation is multiplication, we are going to use the opposite operation, which is division, to solve it. So, and we know that division is displayed as a fraction, right? Yes, division is a fraction. Now, what am I trying? At the end of it all, what do I want? I want the y by itself. I want my problem to say y equals something. The way to do that is I have to get y by itself. And in order for me to get y by itself, I have to get rid of the very thing that is connected to y. In this case, what's connected to y is the number 8. Since we are multiplying, since the original operation is multiplying, we have to divide. Well, Ms. Ramey, what do I divide by? I'm glad you asked. You divide by the number that is connected to the variable. So in this case, 8 is connected to the variable y, and we want y by itself, so we're going to divide by 8. Okay? Remember, same rules. Whatever you do on the left side of the equal sign, you have to also do on the right side. So we are dividing 48 by 8 as well. And just as before in this scenario, once we do the opposite, we are able to cancel culture. This allows the 8s to go away because it is still an inverse operation.
Teacher, please excuse this interruption. Principal honor roll students can now come to the cafeteria with their yellow award. Please do not bring any coats or pins.
Sorry. All right. So the 8s go away and we are left with y. Now, if you look at this technically, this is 8 divided by 8, which is actually 1. So this is really 1y. But we don't have to write the 1 in front of the y. When we see the letter y, we understand that that signifies 1y. It's only 1y. Okay? So we keep the equal sign, and then 48 divided by 8 is 6. So what we're saying is 8 times 6 equals 48. That's what it comes out to. All right? And last but not least, the original operation in this case is division, because it's a fraction. We know that a fraction is division. So since this is division, we are going to use the opposite of division, which is multiplication, to solve it. Again, at the end of this, we want the variable by itself, so we want it to say v equals something. And in order to get v by itself, we have to get rid of the number that is connected to v and keeping it from being by itself. In this instance, that number is 5. So when you are asking the question, how do I know which number to multiply by? Look for the number that is connected to the variable. What would keep v from being by itself? 9 doesn't keep v from being by itself because 9 is on the other side of the equal sign, but this 5 does. Okay? So with that, we are going to multiply. Remember, multiplication is also parentheses. So we're going to multiply both sides, because what I do on this side, I have to do on this side, by 5. Okay? When I do that, it cancels culture. The 5s go away. And that leaves v by itself. I keep my equal sign, and then I simply say 9 times 5, which is 45. So v equals 45. In other words, if I was to replace the v with the number 45, what I'm saying is 45 divided by 5 equals 9. And that is a true statement. And that, my friends, my scholars, sunflower seeds, is how you do one-step equations. It's all about the opposite. So make sure you understand the original operation. Make sure you understand its opposite. And then make sure that you write it down. Try to do mental math. Write it down so that you can ensure that your answers are accurate. Remember, it's not about speed. It's about accuracy. All right. I'll see y'all in a few minutes. We're going to talk about two-step equations. See ya.